Mr. Calbeck here. We're looking at episode 2 of our crash course series on solving. If you haven't watched the first episode on some of the foundations, I'd recommend that you do that. Today we're going to be taking a look at more specifics. How can I solve specific kinds of problems? We're going to give you all the tools that you need to be able to solve almost every problem you're going to see in Algebra 1. All right, we talked last time about how the equal sign it doesn't mean the answer. The equal sign actually means equals. It means that both sides of your equation, again, one whole side and the other whole side, that they're the same. All right, and I want you to remember that. Again, we're looking at the same, and we have to keep things balanced in order for us to solve. The goal of solving, if we want to get the variable, whatever it happens to be, x, a, theta, any of those other letters that we can use. Again, it's not a letter, it's a number. Okay? We're looking for how do we get that by itself. So that's what we're going to be talking about today. So if we want to do this, we talked about yesterday the golden rule of math. If you didn't remember the golden rule of math, it's how you keep your balance beam level and you don't ever fall into the fire. Again, if you didn't remember, here it is again.
One side, you must do to the other side.
By itself. And if you remember last time, we had an x plus 3. This time we have x plus 7. So I'm going to do the same process. I want to take away this extra 7 pieces from this side. I'm going to be subtracting 7 here. So that gives me x plus 7 minus 7. This right here just turns into a 0. And zeros, I don't usually need to write. So I'm going to go ahead and leave that there. That's the only thing left over here. Bring the equal sign down. 12 minus 7, that just equals 5. So we have x equals 5. That's great. What I want to talk about today is how we know that we subtracted here. And what I want you to notice is that on this one, I added 7 and then I subtracted 7. There's a really important relationship between those two operations. An operation in math is something that we do. So adding, subtracting, multiplying, dividing, those are called operations. Okay? But there's a relationship between adding and subtracting. They're opposites. Okay? And we really want you to get that in your head today. These are opposites. Okay? Whenever you want to know what to do in math, when you're solving for a variable, I want you to think about what is the opposite of something. And in this case, I was adding 7, so the opposite would be to subtract 7. All right, let's look at another case and see if we can use this same idea. So we have x minus 3 equals 15. And what we're going to do is we're going to ask ourselves, what's the opposite of subtracting 3? It's adding 3. And remember, we have to do the exact same thing to both sides so that we don't lose our balance on our balance beam. Okay, that's what the golden rule says. So I'm adding 3 over here, and I'm adding 3 over here to keep it all balanced. The 3's, since they're opposites, minus 3 and plus 3, that makes us 0. Again, so I have x plus 0. I don't even need to write that down. 15 plus 3 is equal to 18. Bring my equal sign down as well. And that's it. Okay, so I want you to be looking for the opposites of each operation. Now, some math teachers talk about, instead of opposites, they use the word inverse. An inverse and an opposite are exactly the same thing. If you ever hear your teacher say the word inverse, you can mentally substitute the word opposite. It means the exact same thing. Let's look at a couple other common inverses that you're likely to see. All right, sometimes you might see something like this. Now, there's a couple of things going on here that I want to make sure that you understand. Hopefully, at this point, you realize when there's a number in front of a variable, what that really means is multiplication. Okay, we don't usually write that multiplication sign in there, but I would encourage you, if you're new to this, get in the habit of writing a little multiplication sign between your number and your variable so that you can remember what the opposite of that would be. So the opposite of multiplication, almost all of you guys know this, is division. Okay, now the division symbol that you probably used in other classes looks like this. I don't want you to use that symbol anymore. Okay? When you are dividing in algebra and beyond, I want you to think about using the division bar. So I want to divide like this. Okay? And I'm going to do the opposite. Instead of multiplying by 4, I'm going to divide by 4. And I want to do that on both sides. Okay? This is not a fraction. Again, fractions don't actually exist. For all of you who hate fractions, stop hating them, because all they are is division problem. And if you can think about them as a division problem, life makes so much more sense than it used to. Okay, so you don't have to worry about new rules and stuff for fractions because there's only division problems. And that's what we've got here. Okay, right now I've got 4 over 4. This is 4 divided by 4. Again, not a fraction, it's division. Now some of you have been taught in your math classes that these cancel out. Okay? They don't cancel out. Okay? It doesn't disappear. This doesn't turn into some evaporated version of 4. Okay? 4 divided by 4 equals a number. 4 divided by 4 is 1. And when you cancel something out, it's actually not disappearing. It's turning into a 1. And a lot of times I will draw a big 1 there to remind myself that 4 divided by 4 is 1. It's not 0. It's just a 1. So if your teacher tells you to cancel stuff out, canceling out doesn't exist. Canceling out means that it equals 1. So 4 divided by 4 is 1. So I end up here with 1x. 16 over 4. 16 divided by 4 is equal to 4. Okay? Now some of you might be bothered by this 1 here. In math, every variable, if you don't have a number next to it, always has a 1. I like to think of these as a ninja 1. Okay? Ninjas are stealthy, and if you don't notice them, they'll stab you in the back. Okay? Every variable has a ninja 1 next to it. So be looking for those ninja 1s. If you have a variable that's just naked by itself, it's actually not. There's a 1 hiding right behind it, ready to stab you. Okay, so make sure you remember those ninja 1s. So we've done adding, subtracting, multiplying, and the last one is dividing. So again, remember, you see something like this. Some of you guys are sitting there like, oh my gosh, there's a fraction. You're putting fractions with my variables. Oh my gosh, Calbeck, help, please. No fractions, no. It's not a fraction. It's a division problem. Okay, so when you think about it as a division problem, everything gets so much easier. X divided by 3 equals 21, because I want to do the opposite of dividing here. Okay, so right now this is dividing by 3. The opposite is multiplying. So what I want to do here is multiply. So I want to put a little 3 times the x. Notice it's only in the top of that one. Okay? Because what is 3 divided by 3? Remember, that's a 1. We want things to cancel out. We want to get rid of everything except the variable. And when I cancel all that out, again, it divides into a 1. So I'm left with 1x down here. And over here, I have to do the exact same thing, but I am multiplying by 3. So that's actually, I put that in there on purpose, because your mental math will fail you on this one. You probably told yourself in your head it was 7. It's not. It's 21 times 3, which is actually 63. All right? And again, you don't need to do any more because I don't need to write ninja 1s. You can write them in or you can not write them in. It's important to remember that they're there. Okay? So, crash course. Remember, we're going to do the opposite of each thing, and we're going to do the same thing to both sides. And we're going to remember our ninja 1s. Tune in next time when we start putting a couple of these things together.